In this video, we'll be talking about the reactions regarding alkane. Let's start with the first one, the combustion reaction. It is where an alkane would react with oxygen, usually from the air, which forms the product of a carbon dioxide plus water. This would be the general formula. Let's try some example. Let's try the simplest form of alkane, which is methane, CH4, plus the rest. And now, the last step would be to balance the reaction. In the left side, we have one carbon, and on the right side, we have also one carbon, which is balanced. We have 4 hydrogen in here, and on this side, we only have 2 hydrogen. So we need to add 2 in here in order to have 4 hydrogen. And for this, we have only 2 oxygen. To the right side, we have 2 plus 2 plus 2 multiplied by 1 oxygen is equal to 2. So this makes it 4 oxygen atoms in this side. So we would need to add 2 in here in order to balance the equation. So this would be our balance reaction of the combustion of methane. Let's try another one. Let's try the combustion of a propane, which is C3H8, and copy the rest again. Let's start with the carbon. We have 3 carbon on the left side. We only have 1 in here. So put 3 in this side in order to have 3 carbons on each side. We have 8 hydrogen in here, and we only have 2 hydrogen in here. So add 4 here. So in order to make it 8 on both sides. We only have 2 in here, and on this side we have 3 multiplied by 2, which is 6, and 4 multiplied by 1, which is 4. 6 plus 4 would be 10. 10 divided by 2 would be equal to 5. So put 5 in there. So this would be your balance equation. Let's test again if it's balanced. We have 3 carbons on both sides. We have 8 hydrogen, and we have 10 oxygen on each side. So it is balanced. Just a reminder of you, for the 10 carbon, 1 to 10 carbons of alkane, 1 carbon of alkane corresponds to methane, which is the simplest form of an alkane. Whenever you have 2 carbon in here, it corresponds to ethane. 3 carbons corresponds to a propane. 4 corresponds to a butane. 5 here corresponds to pentane. 6 would be hexane. 7 would be heptane. 8 would be octane. 9 here would be nonane. And 10 here would be decane. As long as they are in the form of alkane, this would suffice. Next up would be the halogenation reaction. The general formula for this would be R-X, which is the alkane. And let's add a halogen. Let's represent this as X sub 2, which is the halogen, which forms the product of R-X, which is the haloalkane, which is the combination of a halogen plus alkane plus H-X which is the side product. Let's try some example. Let's try the halogenation of an ethane, which is C2H6. But in order for you to understand how this works, let us put it into its structural formula. We have 2 carbon here, and we have 6 hydrogen. So this would be the structural form of ethane. And let's add a halogen. We have 4 halogens in here, which is fluorine, chlorine, bromine, and iodine. But you must know some exceptions in here. Usually, they don't use either a fluorine or an iodine. This is because fluorine here reacts very quickly, so they cannot see some results. And iodine here reacts very slowly. And so, what we only have here would be either a chlorine or a bromine as our halogen. Let's try to use a bromine first as our halogen. This was based on the periodic table regarding halogens. So this would be Br2. I forgot to mention, this should be in the presence of heat or light in here. This is because heat or light is very much needed for this reaction in order to break down the halogen. So we can represent Br2 here as Br dash Br. This just represents the bond between these two. You need heat or light in order to break the bond of this. So let's just put it that way. And simultaneously, the bond between C2H in here would also break. And now what will happen? The bromine here, the one bromine that is separated from its bond, would replace the hydrogen in here. So it would be C-Br. And the replaced hydrogen here would react with the other bromine that is separated. And so by that, this would be something like this. So this would be Br now. Plus the hydrogen that is separated, which would react with the other bromine, H-Br, or we can rewrite this as simply HBr. Now if you can see, based on the formula, the R in here represents this structural formula. And the X here this should be H. I'm very sorry for that mistake. This should be dash H. And the H here would be the replaceable hydrogen. The halogen here is the Br. And so you can see that the X here, the 1X, would replace the hydrogen, which forms R-X, which is this one. And the H-X here would be for the replaced hydrogen plus the remaining halogen, which is the bromine, which is that one. Now, if your professor wants you to name the product of this, you would want to put this into its condensed formula, which is, for this one, this is CH3, CH2, Br, which is that one. And so the name of this would be, and so the name of this product in here would be bromo, which is the substituent of bromine. And we have 2 carbons in here, which is the main chain, which corresponds to ethane. So your product in here is bromoethane. Let's try another example. The halogenation of a propane, which is C3H8. So by putting that into its structural form first, we have 3 carbon and 8 hydrogen. And for this time now, let's put our halogen here as the chlorine atom in the presence of heat or light. So by the presence of heat or light, let's put this as Cl to Cl. Because of heat or light in here, it will break the bonds of the chlorine to chlorine bond in here. And it will also break this one, in which the chlorine here would replace the hydrogen, and the hydrogen here would react with the remaining chlorine. And so your product here would be like this, Cl, which replaced the hydrogen, plus the replaced H would react with Cl, which forms hydrochloric acid. If you want to put this into its condensed formula again, this corresponds to CH3. Next up would be CH2. And put this first, which is CH2. And the remaining Cl. And the name of this would be 1-chloro. And we have 3 carbon in here, which corresponds to propane. So your product here would be 1-chloropropane. Next up would be nitration reaction. It is where an alkane, let's say RH, plus a nitrating agent, which is nitric acid, under the presence of a extreme hot temperature, let's say around 425 degrees Celsius, you would need to be extremely in an extremely hot temperature, because you would want this to be in the vapor phase, which forms the product of a nitroalkane plus water. In a nitration reaction, for the nitric acid, you would only need to get the NO2 in here. And what you're left with here is HO. And so what you're dealing with here would be replacing H here with NO2. And for the H here would be reacting with HO, which forms H2O. And for this R, NO2. Let's try some example. Let's try the nitration of a methane, CH4 plus HNO3 under 425 degrees Celsius. 1 hydrogen here would be replaced by NO2. So NO2 would replace 1 hydrogen there, which corresponds to CH3, because 4 minus 1 would be 3, and the added NO2 plus the replaced H here would react with HO, which responds to H2O. If you want the structural formula method, let us do that. CH4, putting it, this would be C and H surrounded by it, plus HNO3. For nitration, we only need the NO2 in there, so we can put this as N NO2 dash HO, which is left after subtracting NO2 in there, under 425 degrees Celsius. The NO2 here and HO bond would break, and the C2H bond here would break, and the NO2 here would replace the H bond in there, and the H here would react with the remaining HO. So this would be like this. C here would be reacting now with NO2, and the remaining one would be forming into water. If we want this to be condensed structural formula, we have 1 carbon, we have 3 hydrogen, and we have the NO2 there, and we have the H2O. So it's a matter of preference whether you want this in the structural formula way or the condensed structural formula way. And if they ask you, what is the product? Whenever you encounter an NO2 substituent, something like that, you would first need to put nitro and the main chain, which you only have 1 carbon here, which is methane. So this would be nitro methane as your main product. Let's try another example, the nitration of butane, which has the formula structure of C4H10 plus nitric acid the presence of 425 degrees Celsius based on the formula here. Subtract 1H here, so this would be C4H9 and get the NO2 on the nitric acid. So this would be C4H9NO2 plus water. Let's try the structural formula. We have 4 carbon here, and we have 10H. Plus, split this apart again. We have NO2 dash HO under the presence of 425 degrees Celsius. The NO2 dash HO bond here would break, and the C2H bond here would break. And once again, NO2 would replace the H here, and the H that is replaced would react with HO, which leaves you with something like this. So something like that, plus the water. Or here, if you want to simplify this, you can just put this into its condensed structural formula. So this would be CH3, CH2, 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 and NO2 plus water. If they ask what is the main product in here, remember we have NO2, so this would be nitro. And we have 1, 2, 3, 4, which corresponds to butane, so this would be nitro butane. But since NO2 here corresponds to the first carbon, you can put this as 1 nitrobutane. Last one would be the isomerization reaction. It is where you would transform a straight chain alkane into a branch chain alkane under the presence of anhydrous aluminum chloride plus a hydrochloric acid. So for this example, we have a butane here under the presence of a anhydrous aluminum chloride plus hydrochloric acid. this is where one carbon here would actually be moved into a branch. So this would be moved into this one or be connected, which forms this one, which is a branch alkane. So this is an isomerization of butane into isobutane. Or if you want the IUPAC one, it would be equal to 2-methyl propane. Let's try another example. Another example would be the isomerization of a pentane. Pentane here would be CH3, CH2, 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 and CH3 by the presence of this one. You can remove one carbon in here and replace it either on this one or this one. This is because you cannot replace it onto this 2H, because if you replace that, this would be simply CH3, CH2, 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 and CH3. You can see here, if you count the chain, it would be 1, 2, 3, 4, 5. It is basically a 5-carbon chain. It is just the same exact original number of carbons. So you would want to put this into the middle one, either upon this tree. So let's just choose to be put on this side. So CH3 in this edge would be put onto that. So this would be CH3, CH2, CH now, because it would be replaced by one CH3 in here, and CH3. If you want to name the product, it would be equal to 2-methyl butane. This is originally a pentane. Basically, isomerization, you do not add anything or subtract anything. It is just another form of their chain. Let us try some problems now. Number 1 would be the halogenation of an 8-carbon unbranched alkane with a mole of bromine. 8-carbon unbranched alkane simply corresponds to a straight chain alkane. So for this, let us put an 8-carbon. 8-carbon here corresponds to an octane. So we have 8-carbon chain plus 18H. So if you want to do the structural formula, go ahead. And let us add bromine. So this would be Br2. But if you want for this to simplify, you can put this into its like condensed structural formula form, so you don't have to draw this structure every time. So for this, let's start with the first carbon. The first carbon here has 3 hydrogen, and for the corresponding next carbon, you can see here that they each have 2 hydrogen. So what we have here next would be 1, 2, 3, 4, 5, 6 carbon that each has 2 hydrogen. Wait, this should be 3. So this should be CH2 6 times. Now this is the condensed structural formula for this one. And for this would be dash C H bond, triple H bond. We just put it this way so that we don't have to draw the structural formula again every time. Plus bromine. Under the presence of heat or light, let's just put it in here. Heat or light. So you can see here that bromine's bond would break. So it will break, and the C2H bond here would also break. And once again, the bromine in here would replace the hydrogen bond, the C2H bond, and the hydrogen that's been replaced would react with the bromine. So this would be, copy this first. And this would be C dash Br, and the hydrogen on this two, plus the hydrogen that's been replaced would react with Br, which makes this a hydrogen bromide. You can actually put H in here as CH2. So this would be CH2Br. And now for your product, you have a bromine here, and it is on the first carbon. So you can put this as 1-bromo. And what we have here would be 8 carbon, which corresponds to octane. And so your product here would be 1-bromo octane plus hydrogen bromide if you want. Next up would be the nitration of a cyclopropane. Now, let's start first with putting a propane, which has 3 carbons. And the cyclo here means that it is in a closed loop. So we can put this as something like this. It is cyclo and we have 3 carbon. So let's make a triangle. This would be CH2, CH2, something like that. Because this is cyclo, this would be a closed loop between this 3 carbon chain. If it's a cyclobutane, this would be something like this. Something like that. But since what we have here is a cyclopropane, this would be it. And nitration, you would add a nitric acid under the presence of around 425 degrees Celsius. We can actually replace an H bond in here. So we can rewrite this as CH2 so this would be C H2H bond and something like that. And we can replace this as NO2 dash HO. And so by reacting this in a vapor state, the NO2 and HO bond would break, and C2H bond here would break, and thus NO2 would replace the hydrogen that's been broken, and the replaced hydrogen would react with HO, so which leaves you with something like this. We can put this as C2H CH dash NO2. So just put that something like that. Plus H2O. And now if you would want to name this, we have a nitro here. So we can put this as 1 nitro. And this, what we have here would be 3 carbon, and it is in an enclosed loop. So this would be cyclopropane. Number 3 would be the isomerization of a hexane. Hexane, once again, corresponds to the 6 carbon and 14 H. So put the isomerization in here. we would need the condensed formula here. We have 6 carbon, so this would be CH3 Just a reminder, whenever you're dealing with or writing condensed structural formula, on the edge here, you have 3 carbon, and on the middle, you have 2 hydrogen, not carbon. As long as it is not connected to anything, but only on hydrogen. And for the isomerization, you would need anhydrous aluminum chloride plus HCl. And so, what you would need here, now, you would need to remove 1 carbon in here and either connect it on these 3 middle parts of the carbon. Let's try connecting it to this side. So this would be CH3, and this would be CH, since 1 hydrogen bond here would be replaced by CH3. So let's just put this as this way and copy the rest. So originally we have a hexane in here, and after isomerization, this is the product. So this would be first carbon, second carbon, so this would be 2, and we have a methyl here, so this would be 2 methyl. We have 1, 2, 3, 4, 5 carbons, which corresponds to pentane. So our product here would be 2 methyl pentane based on the isomer. Lastly would be the combustion of 3 methyl octane. So let us first put an octane in here as a condensed structural formula. We have 8 carbon. Now that we have our octane condensed in here, this is actually equal to C8H18. This should be our case if it's only octane, but we have a substituent here, so we would need to put it in this order. And now, what we want here is the third position of methyl. We can either count it this way, up to 8, or we can also count it that way. It really depends on how your substituent works. But in our case, we can freely choose which way we would want to write because we only have 1 substituent. So let's say this is the third carbon position. So this would be CH3, which is a methyl group. And by that, 1 CH bond here would be replaced by methyl bond. And now let us count the number of carbons that we have. We have 9 carbons, and the hydrogen here would be equal to 20. So this would be C9H20. And add the rest of the formula for combustion. And now let us get straight to balancing. We have 9 carbons in left side, so we need to add 9 here in order to make both sides have 9 carbons. For the hydrogen, we have 20 hydrogen here. We only have 2 in here. So let's put 10 here. So that 10 multiplied by 2 would be 20. So it would be equal. For the oxygen, we only have 2 in here. For the right side, we have 9 multiplied by 2, which is 18. 10 multiplied by 1 would be 10. 18 plus 10 would be 28. And since we already have here is 2 oxygen, 28 divided by 2 would be 14. And now this would be your combustion of 3 methyl octane.